for inviting me for this talk. So I am Midhun M. I'm a Prime Minister Research Fellow at IISER Bhopal. So I work at Climate and Glacier Modeling Lab under the guidance of Dr. Pankaj Kumar. So today I'll be talking about AML-based solution for environmental issue. I'll try to give it very in general way. So I have split this talk into 3 parts. First, I will give an introduction about the topic which I want to explore. In the second part, I'll be briefly talking about my research area, which I have some expertise. So I work on integrating data-driven approaches into climate and weather model. So, and in third part, I will be give some brief overview and the future opportunities in the same sector in other fields, which will be some interesting for all. So let me start with the introduction. So I call it as a boon and pain of 21st century. So let's start with the good things. So we are living in the 21st century, and 2 years before, the entire globe was struck with this COVID-19 pandemic. At that time, somehow things were moving behind virtually, right? So we were able to meet with friends, we were able to enjoy, entertain, everything was going on. So this is possible only because the development of these new technologies. So among that, the artificial intelligence is one to be highlighted. So on the other hand, we have a burning earth to care about. Right. So on one hand, we are in the peak of technological advances, and other hand, we have some issues to concern. So let me give a brief introduction about artificial intelligence and machine learning. So basically, what is machine learning? So this idea, even though it is getting it's a big, gigantic attention now, but this idea evolved around 1959. So Arthur Samuel is he was a computer scientist. So he coined this term machine learning. So which is a field of study that gives computers the ability to learn without being explicitly programmed. In 1998, a scientist from another generation explained it more precisely, like a computer program is set to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience C. Simply keep it on mind, like I'll explain with further examples. So basically, this is a very popular Venn diagram which regarding this artificial hierarchy of AI, ML, and DL. So, and deep learning is mostly accomplished by the neural network. So neural networks, what are these neural networks basically? So as we know, humans are the only intelligence in the known universe, right? So basically our neural network, which is it is also influenced by the functioning of it is influenced by the functioning of our neurons in the brain. So basically, in any neural network, there will be, it is accomplished by several number of neurons, and several neurons contributes to several layers, and these layers contribute to the entire network. And this network, as you can see here, this network is connected like human brain. So let me explain how this works basically. So neural networks basically can be classified into three like ANN, convolutional neural network, and recurrent neural network. So it is a very broad classification. There are many other things which evolved over the last not more than 5 years. So it is very rapidly growing sector. So here I have shown some a GIF file of ANN where how this connection works. So every neural network has a input layer and some hidden layers and an output layer. So basically, I will explain each neuron and how it explained in the next slide. So CNNs are basically image processing neural network, like has many applications. Like we even though we don't know how it works, we are at the end user. So this kind of product, and RNN are basically used for this kind of method is used for language translation, like series data sets and all. So basically building prediction models without explicit programming. That's what the neural network help us to do. So going into the anatomy of a neural network. So suppose we take a single neuron, and this is what happening inside. So this is a neuron taken from an ANN, just for an example. So one neuron will be connected to several other neurons from the input side, right? So, and each neuron has associate a weight and some bias. And this weight plus this whatever the value which is given to from the previous neuron will be multiplied by the weight, and it will be passed on to onto a activation function, and that value will be transferred to the next layer from here. So basically this is what happening in a single neuron. And so what is the use of this activation function? Basically we need to study or approximate very complex nonlinear relationship between data sets. So that's why this activation function adds up, or that's how it accelerates the learning process. So these are some sigmoid, TANS ReLU. These are some common activation functions which are used. So there is this theorem called universal approximation theorem, which states that a neural network with even one hidden layer can approximate any continuous function for inputs within a specific range. So this is very like mathematical. So let me explain in a simple way. So basically, while we develop a model, and first we have to study the phenomenon. Then we have to derive the we have to produce an equation. We have to understand it. Then we have to derive the equation. Then we have to mathematically convert it and find solution. Then we have to every sector computers are being made for that, like to ease this computation. So then we have to code it. Then we have to check it, validate it, and produce results, right? This is a long process. So what this neural network can help is we don't have to explicitly give any functional relation. Like from human understanding, we have some understanding, but always human may cause some error. So what if we have data which we have, and what we have the data which we want? So this neural network simply maps the input to the output, and what we generates, it's a model. So basically a single layer, hidden layered neural network can approximate any nonlinear function, and that's how all come into picture. So this previously what I showed was only happening in one neuron. Like that in a ANN, there are several layers of neurons, like any number of neurons, and unity is strength, of course. So that's how powerful these networks are. So we don't have to program or code anything explicitly. We don't have to say the relationship to it, but the network algorithm will learn it, and that we can use it for further prediction process. So this is a basic idea behind this AAML, what's called AAML. So we are the end users of many services like Google services, social media services, personal assistant, online customer support, fraud detection, fraud recommendation, and this autonomous vehicles like self-driving cars, like that. Then humanoid robots. So there was this AlphaGo, which is a deep neural network program model which beat the best Go player in this world. So, and the Sophia robot which interacts with person with ease. These are all made via the same process. The basic concept is this. So which making models or things without explicit program. So that's the better part of the century. So we are at the verge of technological boom. On the other hand, we are facing this climate change, right? So this has gained some importance last 20-30 years because many things are happening which was not expected. So is the climate change real? So this was a question of the past, but now everyone agrees like climate change is real and it is causing issues all over the world. Right? So this is a diagram which shows the temperature, mean temperature from 1851 to 2020. Usually for climate studies, this 1851, all the studies start with 1851 because that time, that period only this industrial revolution started. And after that, this carbon dioxide concentration started pumping into the atmosphere, which we believe that which is the triggering factor to all of this. So we can see by every year there is a increase in the mean temperature, which essentially we call global warming. This is a time series which from 1880 to 2020 of the same temperature anomaly. This is the difference from a mean relative to the 1951 to 1980. So we can see that the temperature is increasing at least by 1 degree Celsius by 2020. So these data sets are collected from various agencies and they all agree the same. So basically, and the culprit for this rise in temperature is, of course, the carbon dioxide, which is a greenhouse gas. So I hope I don't have to explain it further because like the carbon dioxide acts as a greenhouse gas and it traps the outgoing solar radiation and it essentially warms up the atmosphere, which causes all this environmental issue. So this is a diagram which shows the carbon concentration variability over a period of millennium years. Right? So you can see like over long before even from the birth of Earth, at least this is the highest value of carbon concentration recorded, which is now. So this climate change will cause various issues like polar ice melt, glacier melt, sea level rise, heat wave, forest fire, flood events, and extreme events. So basically, each of these has its impacts, right? Its polar ice melt is affecting this entire circulation system or the atmospheric system is related with the polar ice melt. And glacier melt will affect many regions, like especially this intergangetic plain. So there many the agriculture sector in this area is influenced by the rivers which originate from glacier. So this kind of thing. So last year there was this incident of some glacier blast which caused some sudden flood event and which was even many people died in that event. Right? So sea level rise. So this is a very serious issue which we are concerned. So because most of the human living areas comes in this range. So we are all near to coast, which the population is crowded, and it is essentially gonna affect our habitat, right? Then heat wave, so forest fires, flood events. So forest fires are getting very popular. Like if you check the data for the last 10 years itself, there was all over the globe, in Amazon, in Australia, in Canada, and in places where no one expected these kind of incidents are happening. So we can't say right now whether this all are part of climate, this is caused by climate change, but this is happening right now. And flood events. Which is this, we are a very socioeconomic country, so developing country. So if you check our country itself, there are a lot of flood events happening within the last 10-20 years. So every year, frequently it's happening somewhere, and it's causing a lot of loss in monetary, loss in life, this kind of issues, and extreme events. So this is another serious issue, which maybe 10 or 20 years ago, the cyclones, tropical cyclones, or this kind of extreme events where it was happening, but once or twice in a year, that will be hardly. But now this is just a common news. Like every month we'll hear some cyclone is forming over Bay of Bengal or North Indian Ocean or Arabian Sea. Previously, this Arabian Sea was not that prone to cyclone. Now it is having a large number of cyclones all over. So these are all various concerns which affect our daily livelihood, daily life, everything. So the one thing I can assure is that if this thing is going to persist. So what we saw last 2 years, like what we lived last 2 years with this pandemic we are living now, this is nothing compared to the impacts that may be causing in future, right? So by that, I would like to conclude the introduction section and let me switch on to the application of AML in climate model. So this part I want to emphasize more because this is a domain which I'm working on right now. So basically, let me start with what is climate model. So it's basically a climate model talks about the changes that may happen in atmosphere for a time scale of 30 to 100 years. So how it is possible? How can we talk 30 to 100 years? You might have noticed that sometimes the weather forecast for few weeks may go wrong, right? So then how can we talk about 100 years using this model? And how can we actually rely on that? How can we believe that this is going to happen? So basically, let me give an example of a coin. Suppose we are tossing a coin. So, and we want to predict the state of the coin after some time step. So we can follow the deterministic approach. Like we can formulate some Newtonian mechanics, like equations, differential equations, and solve it for a time t, and let's see what happens. So that kind of problem solving will be very chaotic, right? So even some external factors like a small wind over that region may change the result. Basically. So this is actually, that approach is what we actually follow for weather forecast. So if we want to forecast weather for next 10 days, 1 day, like that, we want to exactly model the atmosphere as a whole. We have to add as maximum components which we can, and we have to solve all of them, and that's how we can follow the weather. We can predict the weather, and that may always have some uncertainty. So that's basically this Lorentz theory, which explains the chaos, right, in this solving this nonlinear system. So suppose, like, we know that a coin has only two sides, either it will be heads or tail. So what if we follow a probabilistic approach? That will make the problem much simpler. And that's how this climate model works. We were actually not care about what's the weather of a particular day in 2090 or like that. It's not going to happen. We can't say such things with climate model. What we can say is that whether the overall trend of this temperature or other things like socioeconomic also. So how it is going to affect under various climate change scenarios. So even though weather and climate seems very same, feels like while hearing it feels like same, but it's entirely different. So in climate model, we follow a probabilistic approach. And I want to introduce this Intergovernmental Panel on Climate Change, which is a United Nations organization. They publish an assessment report every 7-8 years. So right now, the AR6, the assessment report is in production. So there they take the model experiments, the previous data analysis result, many contribution from the scientists all over the world working on the same domain, and they do this. IPCC produce this AR6 like assessment report. So that report is used by the government's policymakers to make essential changes that may help us to reduce what necessary or take actions what's necessary. So